Okay, so the first question was, okay, marker. And eraser. The first question was, you had to identify the angle in the triangle. So hopefully you recognized that it was a 30, 60, 90 triangle. And we know that in a 30, 60, 90 triangle, the angle that's across from the root 3 is a 60, right? What's the sign? Two possible definitions of the sign. Opposite over hypotenuse, and that's if you remember, and it doesn't hurt to write, SOHCAHTOA at the top of your paper. These are the big three, sine, cosine, tangent. So opposite over hypotenuse would be one definition. What's the other one?
Y over R.
Y over R, very good. Either one, didn't need both. What's the reciprocal of the cosine? Secant. Which function is x over y? Cotangent, very good. And then you had to identify another triangle, but this time you needed to know the side, and this is a 45, 45, 90, so x is root 2. That wasn't so bad, was it? Okay, now, we have a couple of things to do today, all right? Very important things. So here's how we're going to start. Our objective is, by the time you leave this room, you are going to be able, without a calculator, to find, let's say, the secant of 120 degrees. All right, so let's just jump in and do this. You're going to be amazed at how easy it is for you to find the secant of 120 degrees. Here's what I'd like you to do. Set yourself up a circle on the coordinate axis system. And in that circle, we're going to draw an angle of 120 degrees. Mr. Stark, what are you doing? Huh?
On your website.
Oh, why are you on my website? Okay. Now, there are a couple of things we need to know before we get started, and I can't take for granted you know these things, so we got to start at the beginning. Whenever we measure an angle in trigonometry, we will always, 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 with one exception that we're going to talk about later today, we will always, always, always start on the positive x-axis. So when I measure 120 degrees, I'm going to start right here, and I'm going to go this way. Positive means counterclockwise or up. A positive angle, we're going to go up. Now, why am I stopping here? Does it make sense to you that that's 120 degrees? Yes, because if I went all the way to here, it would be 180. If I went to here, it would be 90. So 120 is somewhere in between there, right? Is everybody good with drawing 120 degrees? Now, once you get your angle drawn, you are going to create a triangle. And the triangle you create will always be created by dropping a perpendicular to the x-axis. I call this the butterfly bow tie, because depending on which quadrant you're in, you will always have a triangle that is a piece of this butterfly bow tie picture. You will always be drawing one of these four triangles. You will never, ever draw a triangle like this. Never. Your triangle will always be one of these four. We happen to be in quadrant 2 because our angle is 120, so we have that piece of the butterfly bow tie. Now, tell me about that angle right there. It is called the reference angle. Tell me about it. It's 60. You can figure that out, right? This is a 30, 60, 90 triangle then, right? How long is this side of the triangle? It's across from the 60. That was your quiz question. Across from the 60 is root 3. This is the 30, so across from the 30 is 1, and this would be 2? So I have a situation where my x coordinate is -1. Uh-oh, did you catch that that would be -1? Because we are in quadrant 2, we're going left. Y is √3 and R is 2. Now, before you get confused about where these x and y, where's that coming from, Mrs. Ford? Remember, here's the origin. If we want to get to this point up here, wouldn't we go left 1 and up √3? Isn't this the x and the y? And that's, of course, the radius of the circle. Now, wait a second. I wanted the secant. What's the secant?
One of those.
It's the reciprocal of the cosine. The cosine is x over r, so secant would be r over x. So secant will be 2 over -1 or -2. Isn't that easy? Let's do another one. Let's find the tangent of, how about 330 degrees? The tangent of 330. Okay, so here we go. Set up our circle. Now where will 330 be? Remember, we always start here, and we always, if it's a positive angle, we go up. So 330, tell me when to stop. Right there. Does that make sense to everybody? If we went all the way around, it would be 360, right? So we're a little bit short of that. So this is the angle we're talking about. Now I need to create a triangle, and remember, the triangle I build will be one of these. So that perpendicular is going to go straight up, and there's my triangle. Now you need to label everything like we did over here. Start with this angle right here. That's 30. Is everybody good with that's 30? Forgot to turn this off. Make sure you understand why that's 30. You got to get that right or it'll all be wrong. Remember, all the way around is 360. The angle I drew was 330, so there's 30 more there. How long is this side going to be then? 1. Here's my 60, so this would be √3, and this is 2 again?
Isn't it negative?
No, the radius will never be negative. Now, x and y can be negative, but the radius will never be negative. That's a big point. X and y can be negative, but the radius is always positive. So what's my x coordinate here? Remember, here's the origin. You're going to this point, so it's √3. What's my y coordinate? -1. And my radius is 2. Now I want the tangent. Opposite over adjacent, which you can use that. You can say 1, actually make sure that you make that negative then. -1 over √3. Or you can use y over x. Either way, you get -1 over √3 or -√3 over 3. I'll throw you a curveball. See if you can figure out what to do. How about the cosine of 3 pi over 4? Why is this a curveball? Because it's a radian measure, right? What might we want to do first? Change it to degrees? Now we know, because our teacher told us yesterday, that pi radians is how many degrees? 180. So that would be 180. What's 180 divided by 4? 45 times 3. 135. So this is the cosine of 135 degrees. This is not the answer to the question. All you have done is rewrite your problem. You still need to draw the circle, draw the angle, build the triangle, and all that stuff. So here we go. Where's 135 degrees? Which quadrant? Remember, we start here. It's in quadrant 2. How big's my reference angle? 45. So you can label the sides of your triangle. This side will be 1, 1, square root of 2. Anything negative in that picture?
Negative 1.
This one's negative, right? So we have x is negative 1, y is 1, and r is root 2, and we want the cosine. So you can either do x over r, or you can do adjacent over hypotenuse. It doesn't make any difference. You've got a picture here. So you can do adjacent over hypotenuse if you want. Either way, you come out with negative root 2 over 2. Anna?
Are you ever going to give us ones where it's like not a 45, 45 or?
Oh, we'll have zillions that aren't. We just won't be able to do them by hand.
Oh.
Okay? All right, one more curveball, and then we're going to talk about something a little bit different. How about this one? Well, you're thinking this for this, no big deal. I got this. 3 pi over 2. Here we go. What did you say pi was? Pi radians is? 180 divided by 2 is? Times 3? 270. This is the cosecant of 270. That's no big deal. We can do that. Draw a circle. Here's the curveball. Where's 270? It's on an axis. Isn't this 270?
Yeah.
270 is what we call a quadrantal angle. A quadrantal angle is an angle that terminates on an axis. So give me an example of another one. 270 is one. What would be another one? 180. 360, 90, those are all the quadrantal angles. Now here's what makes this a little bit different. You cannot build a triangle. Remember, any triangle you build has to be one of these. And it's impossible to build a triangle if that's your point right there. Do you see what I'm saying? So what do? Well, it's easy. How big is this circle right here? Oh, yeah, I mean in terms of like a radius. Yes, you're right, it's 360 degrees. Oh, do I know the radius of that circle? I knew the radius of this one, right? It was root 2, but I have no idea what the radius of this circle is. You can make up whatever radius you want. So what radius do you want to use? 6? Okay, I always use 1. But Starkey wants to use 6, we'll use 6. Now, if the radius of the circle is 6, and that is a completely random number, you can use whatever radius you want. It won't matter, 1 iota. That's why I use 1, because it's the easiest. But he wants to use 6, so we'll use 6. If the radius of this circle is 6, tell me what the, tell me what the coordinates of this point are right here if the radius of the circle is 6. 0, -6. So we have a situation where x is 0, y is -6, and r is 6. We want the cosecant. What is the cosecant? R over y. So the cosecant here will be r over y, which is -1. Now, do you understand that had I been doing this problem all by myself, I would have used what's called the unit circle. I would have had a radius of 1. So my x is 0, my y is -1, and my radius is 1. Would I have gotten the same answer that Mr. Stark did? Yeah, it's irrelevant. If you have a quadrantal angle, that means you're going to be one of these points right here. Pick a radius, figure out your x and y, and then you can answer the question. Got it?
So for if it was, if they had to find like cosine, and it was 0 over 6, would there just be 0?
What's 0 over 6?
0. But then if it was 6 over 0?
Undefined. Yes, some of the functions can be undefined. Yeah. Absolutely. In fact, if you spend any time looking at the other side of your green sheet, you saw the curves. See all those asymptotes in those pictures? That's where it's undefined. All those things are undefined in various places. Okay. Step 1 done. All right. The other thing on our agenda today is, I don't know if you were, if you caught it or not, but at the very, very beginning, when we drew our first angle, I said every angle we ever draw in trigonometry is going to start here, with one exception. The exception is if you are in a situation where navigation is involved. For example, if you have a ship sailing on a course of, let's say, 130 degrees, that is handled differently than just regular angles. Whenever you have a navigational situation, and you know enough about directions, you know this is north and east and south and west, right? Navigational angles are always measured from due north. So this is 0, due north is 0, and they're measured clockwise. So east is 90 degrees, south is 180, and west is 270. This only applies in a navigational situation. Please don't ever draw a regular angle using this structure. But if you are talking about a ship sailing on a course of 130 degrees, it's going to look like this. This is a course of 130 degrees. Sometimes navigational headings are given as a degree measure. If that's the case, this is your setup. So if you had 300 degrees, you'd come all the way around over to here. Sometimes navigational headings are written in terms of directions, though. So sometimes you'll see something like north 30 degrees west. Now that means start out pointing due north, whatever this one is. Start out, there's my pencil pointing due north. And then veer 30 degrees to the west. That's what this means. Start facing due north and then veer 30 degrees west. So if you had one that said, you could do that, right? That would mean start out pointing due south, and then veer 10 degrees to the east. Sometimes they just say this. Any idea what that means? If there is no angle attached to that, then that means exactly northeast, which would be the angle or the vector in between north and east, and guess what that angle is? That's 45. If there is no angle given to you, if it just says northeast, the implication is it is due northeast, it's 45 degrees. North, northeast. Any idea what that means? That means the north side of northeast. So here's northeast right here. Everybody got that? You have a north side of that vector and you have an east side of that vector. North, northeast means split the difference here. This is north, northeast. What do you think this one is? East, northeast. Yep, that's exactly right. And that is exactly split. So this angle right here would be 22.5 degrees. If there are no angles mentioned in the problem, then it's evenly spaced. You just bisect. Okay? So somebody asks you, as they will in your homework, to draw a picture of this. Draw a picture of that. East, southeast. Okay, well, first of all, this is southeast. Would you agree with me? East, southeast would be here. As opposed to this one, which would be south, southeast. Yeah, you got it. Oh my gosh, Katie Kine, you are so bad for my self-esteem. You make me think I'm boring.
You're not. I'm just really tired.
You told me you weren't tired. All right, here's what I want you to do now. I want you to get your packets out. Oh, we have one more problem to do. We have time, but I want to make sure you're clear on homework. The second page of the big packet says trig functions of special angles, evaluate without a calculator, and there's 10 of them. The second page of the big packet. See what I'm talking about? That's those 10 problems. By the way, the answers are on the back. Those 10 problems, that's your homework along with 3 book problems. 2 of the book problems are like this, navigational things. The other book problem is one similar to one we did yesterday. I want to do another example. Here's the situation. I have a tire with a radius of 14 inches. It is traveling at a speed of 18 miles an hour. I want to know how many RPMs. Okay? So I have my bike tire, 14-inch diameter, or 14-inch radius. It's traveling 18 miles an hour. I want to know how many times it's spinning per minute. So I need to somehow get from 18 miles per hour, I have to somehow end up with revolutions per minute. That's my objective. So anybody have a thought on how we might start?
60 minutes an hour.
All right, so we got hours, we need minutes, so that's an easy one to do. So we'll say that 1 hour is 60 minutes. Now, pay attention, this is miles, right? And my radius is in inches, so we might want to get something going that way. Does that make sense? So, what do we know about miles?
Miles to feet is
5,280 feet are 1 mile. And then,
how many feet? 150 revolutions.
let's get inches going here. Let's at least get that done. So that would be 12 inches is 1 foot. So what have I got so far? Inches per minute. So somehow I have to get from inches to revolutions. I got to get from a distance to a revolution. We talked about this yesterday. What's the key? What's a revolution? A revolution is a circumference. So 1 revolution is a circumference. And what would the circumference be if the radius is 14? 28 pi inches. So 1 revolution is 28 pi inches. Well, wait a minute. So now the inches are gone. What do I have left, you guys? Revolutions per minute. Isn't that easy? So then you can do multiplication. I do want to remind you, this is always an issue, it seems. When you do the division, particularly this one, make sure that you are using parentheses because you are dividing by both the 28 and the pi, okay? Make sure that you're doing that division correctly. All right, you learned a ton. I am so proud of you. Okay, tonight you'll practice that. I want to give you one more thing. The exam is approaching, so I'm giving you your exam review materials.
Maybe 35.
This is just in case you want to get a head start. So please make sure you get one of these things. Gary, get your head up now. Look excited. Okay. Now you can